Hello everyone, this is ECE100, class number 6. In this class we're going to talk about batteries. So for batteries, I think you may have done this experiment in your elementary school, trying to find some voltage and current from a lemon. So what's happening over here? So you might do the same thing in your elementary experiment. You have a zinc nail over here, which is we call about cathode. So this is this is our anode, and we have a copper penny over here. This is our cathode. And also we have inside this lemon, we have acidic solution here. So what's happening? What's happening over here, your reaction of copper, zinc, and acidic solution produce extra electron. So that's extra electron normally goes from zinc to the copper. So if you connect it, if you make a connection over here from zinc to the copper through a light bulb, let's do this with the light bulb over here. So if you make a connection from zinc through a light bulb to the copper here, so this is your bulbs over here. So then electron will go from your zinc to copper. That means your current will go from copper to zinc. That means your light will lights up if you're lucky. And also in this solution is produce extra hydrogen gas. So hydrogen gas will go to the atmosphere. So that's what's happening over here. Interesting fact about that. Car battery, 12 volts car battery, right? To make a 12 volts car battery, you need about 6 million lemon to make a 12 volts car battery. So now you can imagine that how insignificant this lemon battery is. And here's the link for YouTube video with the lemon battery testing. So that's interesting. You can watch it. So battery capacity is different than your energy. Your energy, we describe them in joules or kilowatt hour. But in battery capacity, we describe them amp hour or milliamp hour. So that is, C is basically your I times T. I is the current, T is the time. So current times time. So when you say a 1000 milliamp hour AAA battery is basically saying that it can supply 1000 milliamps for an hour. That's what it's saying, 1000 milliamps for an hour. But if you take 2000 milliamps, it can only last for 30 minutes. If you take 1000 milliamps, it's going to last for 1 hour. If you take 100 milliamps, it's going to last for 10 hours. If you take 10 milliamps, it's going to last for 100 hours. So that's what it's saying. So it has capacity of 1000 milliamp. And if you take it all, it can last. If you take it at the rate of 1000 milliamps, it can basically last for an hour. This the 1000 milliamp hour is the capacity of the battery. It depends how much you're taking out, and that's what it's gonna last. So there's a something called C rate for battery. Is basically rate of discharging or charging. So if you're discharged at the C rate, it's gonna last an hour. If you discharge is slower than C rate, it's gonna last for longer. So over here, if you discharge it for 0.2 C rate, then it's going to last for 5 hours. If you do it for C rate, it's going to last for an hour. If you and so on. But sometimes if you do it 1C, it's going to last for less than an hour, and so on. Every battery will come with this chart over here for you, so you can decide that how is battery discharging. One important thing is that how the battery is holding the voltage. Let's say this one is starting from 2 volts, 1.9 volts, 1.8 volts, and let's say if you're looking for around 1.8 volts that you need to know, and you need 1.8 or higher, so maybe and longer time, maybe you want to follow this curve over here, discharging them at 0.2 C. All right. So if you discharge them with a high current, it's gonna last less, and also voltage is gonna go down very quickly. You might not be able to use it for long enough. So here are some battery curve over here. So alkaline and also nickel metal hydride, this side here. This is a very good battery that hold the voltage for long time, flat voltage curve. It's very good for that, but problem is that it has some safety issues to solve. So that's what we're working right now in the research lab. If that happens, that would be very good battery for us. And we normally use alkaline or lithium non-dischargeable batteries. That is not bad. You can see the curve here is not bad, but it's not as good as nickel metal hydride. And also have lead acid battery, very common for car, and also for a solar system backup batteries. And nickel cadmium is good. Lithium ion is also very promising. Lithium polymer is also very promising. So these batteries are in the research lab right now, mostly trying to make sure that it's safe for environment like high temperatures, or also in a confined place. So that's what they're testing those batteries right now. And 1.5 volts cell, if you have triple A battery, it has around 1000 milliamps. If you have double A, you have around 2400 milliamp hour. And C size could have as high as 8000 milliamp hours. So that you can see that C size has more capacity than anything else. And your 9 volt battery would have basically 650 milliamp hour. Right? So if you buy a cheaper battery, you might not be able to use it for longer time, because when it discharges, it's gonna drop the voltage very quickly. That is not usable for a longer time. So sometimes cheaper battery company basically try to cut the corner, and that does not do a good job for the consumers. So battery can be connected in series and can be connected in parallel. So what does it mean? When you have a battery also have internal resistance. You have learned them in maybe in your high school class. If not, battery is not resistance free. It's an internal resistance. So if you that's what happens if you try to draw more current, is you lose more in the internal resistance, and that's why you get less voltage at the terminal. And so you should not drain the battery very quickly. That means you're going to lose more energy inside the battery with the internal resistance. So there are two different connections you can do, series connection and parallel connection. This is a series connection right here. So you put them, stack them one after another. So let's say if this is 1.5 volts, this is 1.5 volts. If you now get from here to here, you get 3.0 volts. But doing that in series connection, you are increasing the voltage, but not the capacity. Capacity is still the same, because each of the battery is basically give you the same current. So you cannot increase the current, so capacity stays same. So series connection, your voltage increases, capacity stays the same. In parallel connection, 1.5 volts, 1.5 volts. So you have still 1.5 volts here. Your voltage is not increasing, but now you have two pipeline here, two currents. So your current basically doubled, right? So I will give you 2I here. That means your capacity increased twice. So its capacity increases voltage same. So series connection, you have voltage increase, capacity same. In parallel connection, your capacity increases, voltage stays the same. So to get a quick example for this over here, let's say that you have a single brand C-cell alkaline batteries of voltage 1.5 and 8,000 milliamp of capacity. If we attach two cells in series, then attaching 60 ohm resistor, how long it will take to deplete the battery series, right? So we're gonna put them in series, two batteries. I'm gonna put them two cell over here. Then you're connecting to a 60 ohm resistor, right? So 1.5, 1.5 volts, 1.5 volts. So I have 3 volts here now. From here to here, I have 3 volts, right? So now, how much current going over here? So let's find the current over here. I would be voltage 3 volts over 60 ohms. That should give you, let's see, 3 volts over 60. I don't have a calculator here. Let me find the calculator. So I'm gonna get 3 volts over 60 ohms. I'm gonna get 50 milliamps, right? I'm gonna 50 milliamps. So I'm gonna get 50 milliamps continuous current out of here. So then my capacity is IT, right? And a capacity is 8,000 milliamp hour. My I is 50 milliamps. Then I'm gonna find the T. So your T would be 8,000 over 50, 160 hours. So if I do that, my battery will run for 160 hours. So now, if I, instead of that, if I now, let's say, I'm gonna connect them in parallel. If I do in parallel, so what will happen? This is my connection over here for the parallel, right? So then each of them will have 1.5 volts, 1.5 volts. So the current over here would be 1.5 over the current over here is 1.5 volts over 60 ohms. That will be half of that, so it will be 25 milliamps, right? So now my capacity over here, I have two of them in parallel, so I have double the capacity now. So my C is 16,000 milliamp, double the capacity, right? So now my T would be C over I. If I do the math over here, C is 16,000 over 25. Look at that, it's gonna run for 640 hours now. Right? So now you see how your connection can change if you do in series or you do in parallel. All right. This is basically right here what I have done. And for the submarine battery, submarine has a big pack of batteries. So those batteries has let's say 100. Can supply up to 1500 amps for 3 hours continuous. So that means is 4,500 amp hour capacity for the battery. You can calculate from there. So and if we go into kilowatt and joules, we're gonna do in the class how to find the power and how much energy is there. We're gonna do in the class. And also Tesla, a car can drive more than 270 miles now, and they have 7,104 lithium-ion batteries in there, and that each of them has 3,400 milliamp hour and 3.6 volts. So it's a huge battery pack out there. It's not one battery, it's not two batteries, it's like 7,104 batteries in Tesla. So we can also do this experiment example in the class. So I think that's all for today. This is the picture of Tesla Gigafactory in Nevada. Look at that, the huge research lab for the Tesla. I mean, we're looking at electric car or anything with electric only viable if we have a good battery. So that's what everyone is basically spending research money now. All right, I will see you for the next class.